Hello students, judges, and families. My name is Ahan Gode, and today I will be talking to you about my project, the ultrasonic car sensor. Have you ever wondered why accidents and collisions still happen to this day? In order to find out the most efficient solution to this problem, we must think about what causes the most collisions in this world. In this case, 33% of all drivers have accidents due to distracted driving. This is a serious problem since although there are fines for being on a device while driving, people still use their devices while driving and therefore don't give their full attention to driving safety. This is where my project, the ultrasonic sensor, comes to help. Purpose. The purpose of my project is to help drivers and pedestrians be more safe on roads and lower the amount of collisions that happen every day. This doesn't just help save lives, but can reduce the amount of physical and emotional trauma effects that happen during or after a collision. This is the purpose of my project. Materials. The materials I chose are as the following. The Arduino Uno Rev 3, which is this board. The reason why I chose the Arduino microcontroller is because Arduino is easy to code and is simple to connect hardware projects to the microcontroller. The Arduino is also very efficient with prototyping and can compile sketches very easily due to the coherent logic board. This allows for quick connectivity between the Arduino and the hardware. This is why I chose the Arduino microcontroller. The next object I chose for my project is the RGB LED. The reason why I chose the RGB LED is because the RGBs can change into multiple colors, thus reducing the amount of space needed on the breadboard, making it more cost efficient and energy efficient. The RGB LED is also a visual to warn the motorist if their vehicle is too close to the object. This is why I chose to use the RGB. Another object I chose is the ultrasonic sensor, which is right here. The reason I chose the ultrasonic sensor is because ultrasonic sensors can detect how far away an object is and are more reliable than IR or infrared sensors, and are very accurate compared to other sensors. Ultrasonic sensors are also not affected by weather such as dust, rain, snow, and etc., and are capable of sensing all material types. I was also inspired to use the ultrasonic sensor because of backup cameras, since both would work in a similar fashion. This is why I chose the ultrasonic sensor. Another piece of equipment I chose in my project is the breadboard and wires, which is this plastic stand and the wires are over here. The reason I chose the breadboard is because it is a prototyping board and is used when hooking projects together without the need of soldering in case a mistake happens. I used the wires to connect these components together and make sure that they all worked. This is why I chose the breadboard and wires. Another object I chose are the resistors, which are these over here, these tiny blue things. The reason I chose the resistors is so that the RGBs won't burn out. LEDs need a current of about 20 milliamps. The Arduino gives 5 volts, which is about 400 milliamps. I used a 200 ohm resistor so that the LED won't burn out because of the overflow of electricity. The final object I chose is the active buzzer, which is this black cylindrical object. And the active buzzer can send a sound through the Arduino like a speaker. This is used so that the driver can be warned if their car or vehicle is getting too close to an incoming object. I will now be showing a demonstration of my project. So, I have this brick here, which I'm going to use. So when it is a bit closer to the ultrasonic sensor, the green LED starts to turn on. If I move it a bit more closer, the yellow LED turns on, and the active buzzer also turns on, emitting a sound. Now if I put it really close, the red LED turns on and the active buzzer makes a really high-pitched sound. So, these are my results. My findings include that the RGB LED glows green when the object is less than 50 centimeters and greater than 20 centimeters in range. The RGB LED glows yellow when the object is less than 20 centimeters and greater than 10 centimeters in range. If the object is, and the buzzer vibrates at 500 Hertz. If the distance is less than or equal to 10 centimeters, the RGB LED glows red and the buzzer vibrates at 1000 Hertz. The serial monitor, which is connected to the Arduino via a computer, also prints how far away the object is from the sensor. My project was to help keep roads and streets more safe by making the ultrasonic car sensor to help motorists be more aware of their surroundings and to limit the number of accidents and collisions that happen in Ontario. This sensor does that since it alerts the driver of an incoming object, whether a pedestrian or vehicle. This helps the driver be more aware and can help them understand more about road safety. This device can also warn the driver before an accident happens, since it starts to warn the driver when the object is 50 centimeters and closing. The Arduino can also calculate the correct measurement between an object and the ultrasonic sensor via the serial monitor. My project met my design criteria by functioning well and limiting the amount of space needed for the hardware and took up less space on the dashboard of the vehicle. My project was also a success because it works efficiently and is accurate because calculations were made correctly. Some changes I would make to the design of this project would be to add Bluetooth to the ultrasonic sensor and Arduino to keep the wires from getting tangled or from tearing. I would also make a case for the ultrasonic sensor to make it more user-friendly than soldering the sensor to the vehicle. Instead, I would attach a neodymium magnet so it can be kept securely on the frame of the vehicle. Another change I would make is to integrate PCB boards instead of using a breadboard so components can be dismantled as easily on a breadboard. This can also help lower the size of the motherboard of the sensor to help make it easy to place on the dashboard of the vehicle. Thank you for listening to my presentation.